Imagine this. You walk into a lab and see a rock floating above a metal track. A guy literally running on top of a liquid. Water that freezes on command. A spinning wheel that refuses to fall. And a night sky in Canada that looks like it's been photoshopped by a god-tier designer. No CGI, no camera tricks, just physics. Today, whether you're watching this from New York, Toronto, Vancouver, or literally anywhere on Earth, we're breaking down 5 physics phenomena that look like straight-up magic, but are completely real. And the best part? After this video, you'll be the person at the party who can explain them in a way that actually makes sense. Let's go fast. First one, the floating rock. Picture this. There's a little black rock sitting on a magnetic track. Someone pours liquid nitrogen over it. A few seconds later, the rock starts floating in midair, sliding smoothly along the track like a tiny ghost train. No strings, no hidden magnets in your hands. This is superconductivity in action. When some special materials get really cold, they become superconductors. That means their electrical resistance drops to almost zero. And they do something crazy. They push magnetic fields out of their insides. That effect has a name, the Meissner effect. So when you put a superconductor above a strong magnet, the magnetic field tries to go through it. The superconductor basically says, nope, not allowed. The result is a repulsive force that holds the material in the air. It levitates. To your brain, it screams magic. To physics, it's just fields and electrons doing their job. In real life, this isn't just a party trick. Maglev-style trains can use similar principles to glide with almost no friction. Those giant MRI machines in hospitals that scan your brain and body use superconducting magnets to create incredibly strong magnetic fields. And labs across North America are pushing high-temperature superconductors for things like quantum computers, super fragile machines that might someday break problems your laptop can't even start. Next time you see a floating object on a rail in a science video, don't assume it's CGI. It might just be physics flexing on you. But okay, you're thinking, that's cool, but I don't have liquid nitrogen at home. Fair. So let's move to something you can actually do with stuff from your local grocery store. Number 2, walking on liquid. You've probably seen this clip. A pool filled with some white liquid. A person runs across it like they've unlocked the walk-on water cheat code. But when they stop moving, they sink. Looks fake? It's not. It's a non-Newtonian fluid. And you can make it with cornstarch and water. That's it. In the US or Canada, you can find cornstarch in literally any supermarket. This mixture behaves differently depending on how hard you hit it. If you hit it hard, it acts like a solid. If you touch it gently, it flows like a liquid. The science word for this is shear thickening. When you apply a strong force, the tiny particles in the fluid get jammed together. They don't have time to move around each other, so they lock up and behave like a solid. But with slow, gentle movement, they have time to slip past each other, so it flows. So when someone runs across the surface, each footstep hits fast and hard. The fluid stiffens for a split second. Their feet don't sink as long as they keep moving. Stop moving, and gravity wins. You sink. This isn't just a YouTube stunt. Engineers are studying non-Newtonian fluids for body armor and protective gear. In normal conditions, the material is soft and flexible. Under impact, like a hit or a bullet, it instantaneously stiffens and helps absorb the force. You can even drum on a bowl of this stuff and watch little spikes of liquid jump with every beat. It looks like alien life trying to escape the bowl. So yeah, walking on water is still not happening, but walking on cornstarch? That's just physics being playful. Now let's go from weird liquids to something that looks like it's breaking gravity. Number 3, the wheel that won't fall. Take a bicycle wheel, hang it from one end by a string, and let it just dangle. It drops straight down, obviously. That's gravity. Now spin that same wheel really fast, and then hang it by one side again. This time, it doesn't fall. Instead, it stays almost horizontal and slowly rotates around the string like it's possessed. No, it's not cursed. It's a gyroscope. A spinning object has something called angular momentum. That's just a fancy way of saying it strongly prefers to keep spinning in the same direction. If gravity tries to tilt the spinning wheel down, directly tilting it would mean changing the direction of that angular momentum really quickly. Physics hates big, sudden changes like that. So instead of just falling, the wheel responds by turning sideways, slowly rotating around the pivot point. That sideways turning is called precession. It feels like the wheel is defying gravity, but what it's really doing is following the rules of conservation of angular momentum. You experience this every day. Bicycles and motorcycles use the same idea. Spinning wheels act like gyroscopes and help you stay balanced. That's why riding fast feels more stable than riding slowly. And planes and rockets use gyroscopes to know their orientation in space, which way they're pointing or turning or tilting. And your phone? The reason your phone knows when you rotate it from portrait to landscape is because there's a tiny gyroscope sensor inside measuring how it's spinning. So that magic trick where a spinning top sits on a string or balances on the edge of a glass, it's not cheating gravity. It's just using momentum in 3D. Now from strange wheels, let's head back to something in your freezer that can also look like a glitch in reality. Number 4, water that freezes on command. You pull a water bottle out of the freezer. You expect ice, but when you look, the water's still liquid. Weird. Then you tap the bottle or pour it into a glass with an ice cube, and suddenly the entire thing freezes right in front of you. It looks like the video is reversed, but it's real. This is supercooled water. Normally, water freezes at 0 degrees Celsius or 32 degrees Fahrenheit. But if the water is very pure and the bottle is very smooth, water can actually be cooled below its normal freezing point and still stay liquid. To form ice, water molecules need a kind of seed, a nucleation site, a place like a bit of dust, a scratch on the bottle, or an existing tiny ice crystal, where the first little cluster of ice can start to grow. If there's nothing to grab onto, the water becomes supercooled. It's colder than its freezing point, but still liquid. It's like a crowd waiting in silence. Then you give it a little tap, or pour it over an ice cube, and suddenly, go, go, go. The molecules snap into place and the freezing process races through the liquid in seconds. This matters a lot in the real world. In cold climates like parts of Canada or the northern US, tiny droplets of water in clouds or on airplane wings can become supercooled. When they finally find a surface to freeze on, they ice up instantly, which is a huge safety concern in aviation. You might have also seen viral videos in winter where someone throws boiling water into freezing air, and it turns into mist or snow mid-air. The droplets are tiny, they cool very fast, and they can freeze almost instantly. So yes, you can have a bottle of liquid water that turns into ice almost like you've pressed a freeze button. No editing, just thermodynamics doing party tricks. But if you want something even more dramatic, not just a bottle, but the entire sky putting on a show, that takes us to our last phenomenon. Number 5, the glowing sky. If you live in or visit northern places like Alaska, Yukon, or parts of northern Canada, there are nights when you walk outside and the sky looks unreal. Huge flowing curtains of green light, faint streaks of purple and red, the entire sky flickering like it's alive. It's not a projection, it's not city lights, it's the aurora, the northern lights. The story starts about 150 million kilometers away, at the sun. The sun constantly sends out a stream of charged particles called the solar wind. Earth, luckily, has a magnetic field, like a giant invisible shield. Most of those particles get deflected away, but near the north and south poles, the magnetic field lines curve down and meet the atmosphere. That's where some of those particles manage to sneak in. When they slam into atoms and molecules high in Earth's atmosphere, they get excited, literally. And when they calm down again, they release that energy as light. Different gases and altitudes produce different colors. Oxygen high up gives green or red tones. Nitrogen gives blue or purplish tones. So the sky becomes this giant glowing canvas. If you're in the US or Canada, you might see aurora alerts pop up online with maps showing where the lights might be visible tonight, kind of like a Northern Lights weather forecast. People will drive hours away from city lights, set up cameras in the cold, and just wait, hoping the sky explodes in green and purple. It feels spiritual, mystical, unreal. But at its core, aurora is just charged particles, magnetic fields, and thin air turning into a light show. So today, we watched physics do 5 magic tricks. Superconductors making objects levitate over magnets. Non-Newtonian fluids letting you run on liquid like it's solid. Gyroscopes, spinning wheels that seem to fight gravity. Supercooled water that freezes instantly on command. And auroras, entire skies glowing because of the sun and Earth's magnetic field. No spells, no secret wires, just particles, forces, and a universe that's way cooler than any movie script. If you want a part 2, like 5 science experiments you can actually do at home, or 5 movie superpowers that are secretly based on real physics, drop a comment and tell me what you want to see next. And whether you're watching this from the US, Canada, or anywhere on this planet,
Hit like, subscribe, and turn on the bell. So next time reality looks like magic, you'll know it's probably just physics showing off again.